All right, this is Mr. Gillum, and today we're moving on to divide multi-digit numbers. This is Lesson 8, Day 1 in the Practice and Problem Solving book on page 79. The example says that a farmer sells milk in crates that hold 18 bottles. She has 612 bottles of milk. How many crates can the farmer fill? So before I look at any of this stuff over here, let's just talk about the problem itself. It says that the crates hold 18 bottles, and she has 612 bottles. And we need to know how many crates the farmer can fill. And so I know that if we have 612 bottles, however many crates that we need is divided by 18, because 18 bottles fit in one crate, and there are 612 bottles. So every time 18 goes into 612, that's another crate that's filled. Okay, so 612 divided by 18 is what I'm thinking. It's a pretty straightforward problem, but what I want to talk about is how to do the partial quotient method, as well as how to do the algorithm or long division. Now, traditionally, you're probably familiar with the algorithm, the long division. So 612 divided by 18 like this. Your book shows the partial quotient method the same way, except it's organized a little differently. The numbers aren't necessarily the same, but it's set up the same way. That can be a little confusing. So what I'm going to do right now is just the long division part. 18 plus 18 plus 18, that's 36, 54. So I know the next one would be, if we did another 18, the next one would be 62, 72. So 72 is too big for 18 to fit into 61. It only fits in 3 times. And 3 18s makes 54. So when I subtract, I get 72, I bring it down. Okay, well, I'm glad that I figured out that 4 18s equals 72, because now I know that 18 goes into 72 4 times, and I can do long division. So I know that 34 crates would fill all the bottles, or all the bottles would make 34 crates. So that is the traditional, we call it the algorithm for division. It's called long division. That's what we usually do. But there's another way called the partial quotient method. So now I'm going to show you the partial quotient method, and that's still 612 divided by 18, but we're going to set it up a little differently, and so I want to show you how they set it up. It looks like the algorithm for long division, but it's a different kind of method. We're going to use what the book refers to as a friendly number. Okay, that's just a friendly number is just a number that's a good number to estimate with. So I know that 18, I know my math facts probably a little better than some of you, but I know that 18 plus 18 plus 18 is 54, okay? And I can add that up, and I know it's 54. To me, 54 is close to 612, so I could pretend that 540 is close to 612 as well. So this is much different than long division, and I don't necessarily like setting it up like the algorithm for long division, but that's how the book does it, so that's what we're going to do. So I know that 30 18s will get me to 540, okay? Because 18 times 30 equals 540. So I know for sure 30 18s will fit in. I have left 72. That's my remainder at this point, okay? So 30 18s fit in there, and that leaves 72 left. I know 4 18s will go into 72. 1, 2, 3, 4. And so another 4 18s would fit in as well. So altogether 30 would fit in plus another 4 would fit in. So we use a friendly number to make the numbers smaller to do our calculations with. It's called the partial quotient strategy. So 30 plus 4. Okay, again, I knew that 30 18s fit in. That would make 540. That left me with 72 left over that I hadn't accounted for yet. I know that there's 4 18s and 72, so 30 fit into 540, 4 fit into 72. Altogether, that made 34. Okay, that's the partial quotients method. It's a little different. I'm actually going to go back here and explain this again. So this is how they set it up as well. This number up here plus this number up here, that's the actual quotient there. Again, I want you to compare these together. There's different numbers being subtracted on each one. For the algorithm, it's just the traditional, how many times does 18 go into 61? Carry down the numbers. And the partial quotients, you think of what we call friendly numbers, and that's what you subtract. And you add whatever's necessary to add for the remainder part. So that's it for today. Hopefully that partial quotient